what is the absolute value of a number? Well, the definition of absolute value is a number's distance from 0. So the absolute value of 5 is equal to 5, because 5 is located here. And if we look at this distance between 0 and 5, that's 5. Whereas the absolute value of negative 3 is equal to 3, because negative 3 is located here, and this distance is 3. So a shortcut that people sometimes try to remember is that the absolute value of any number is positive no matter what, because distance can't be negative. So the absolute value of anything would be the positive value. So let's take a look at an absolute value equation, because this is a little unusual, and I'll try and make it as clear to understand as possible. Let's say we had the absolute value of 3x plus 2 is equal to 5. Alright, actually let's change this slightly. I want to be a little bit more complicated because it covers an issue we'll have later. So let's say that's minus 1 is equal to 4, which is going to become the same thing as I had up there a minute ago. Alright, so the first thing you want to do is isolate the absolute value. Okay, so we're going to add 1 to both sides, which is going to put us right back where we started, but at least it touches on this idea that you'll want to isolate the absolute value. Alright, so at this point there are two possibilities. If this number, so these are the two possibilities. If this number, which we don't know what it is positive, this will stay the way it is. So we'll have 3x plus 2 is equal to 5. That's if this number is positive. And we can solve that pretty easily. Okay, I don't know why I put an equals there, but I did. I won't deny it, but it doesn't belong there. And that'll leave us with 3x is equal to 3, and x is equal to 1. So that's one possibility. The second possibility is, since we don't know what the value of x is, it could make this expression negative. And if its expression is negative, then the absolute value would reverse the sign of all of these terms. So we would get this, negative this, the opposite sign of this. Okay, which is negative 3x minus 2 equals 5. We do the same thing to solve it. We add 2, we'll get negative 3x is equal to 7, which means x is equal to what was that, 7 divided by negative 3, so it's negative, and that's 2 1/3, 2.33333. Alright, so this actually is two answers, depending on whether x is positive or whether this expression is positive or negative. So that's when this expression is negative, we assume all of its signs have to change. Because if this was negative, the absolute value would change the sign of all of these values. That's why this possibility occurs. Okay? So this has two answers. Alright, so let's change this a little to how do we solve absolute value inequalities, because this is pretty easy. You make one normal and you make one with the opposite sign. So it's the same thing for inequalities. So let's actually do that now. Let's erase all of this. Whee! And everything's erased. Alright, so change the aim even. The aim is now, how do we solve absolute value inequalities, things that aren't equal. Solve n-graph. Alright, so let's make another example. Let's say we had, I don't know, 3x minus 5 is greater than or equal to 6, whatever, doesn't matter. Alright, so just like before, we want to isolate the absolute value. So first thing we want to do is get rid of this 3. Since this 3 is being multiplied by our absolute value, we can cancel that out through division. Whatever we do to this side, we do to this side. We'll divide by 3 on both sides, and that'll leave us with the absolute value of x minus 5 is greater than or equal to 2. If this was a negative 3, we would have to reverse the sign of the inequality, but it wasn't, so we don't. So here are our 2 possibilities. Path 1, if this value is positive in here, it will not change signs. X minus 5 will be greater than or equal to 2. And path 2, if that value is negative, this value, it'll have the opposite sign. So let's solve them both. That'll give us x is greater than or equal to 7. And this one will give us negative x is plus 5 is greater than or equal to 2. Negative x is greater than negative 3, which means x is less than 3. Divide both sides by negative. We'll have to reverse the inequality. So those are the 2 possibilities. So I left out the equals parts. So we have 2 different answers. So on our number line, we have to graph them both. So it's either this or this. This is an or inequality. So an absolute value inequality becomes an or inequality. It's either this answer or this answer, just like with the equation. So here's our number line. Alright, so either x is greater than 7. So here's 7. We have a closed circle here. Values that make this true would be located that away. Or x is less than 3. So this is 3, less than or equal to 3. Values that make that true are located over here. So this would be the graph of this absolute value inequality. Alright, so it's equally as difficult as an equation. You just need to remember that isolate the absolute value, which generates 2 possible outcomes. And it's whatever solves one or the other. So they have 2 different answers, so you have to put them together. Okay, so there are no AND inequalities with absolute value inequalities. And while we have extra time in this video, because it's pretty short, I wanted to mention something I forgot to mention in a previous video on graphing the solutions of graphing inequalities in general. So I'm going to erase this, and we're just going to briefly talk about that. That's supposed to be an eraser. Erasing everything. Bang. Gone. Alright, so if we have x is greater than 5, or x is greater than 6. Let's do that in a different color. Alright, so x is greater than 5, or x is greater than or equal to 6. Let's take a look at that. Or. Alright, so here's the number line. So this is or, so we graph them both, not just their overlapping areas. If we have x is greater than 5, so values that make that true would be located to the right. And if we have x is greater than or equal to 6, at 6 we have this. So you'll notice that these actually are entirely covered by just x is greater than 5. So this is equal to x is greater than 5. Don't really want to do that in that color. So yeah, this is the equivalent statement of x is greater than 5. You can look at the number line. All of these values are covered here. This is equal to this. Alright? So that's one thing that can happen. Sometimes the shared inequality generates a single inequality. So let's look at another possibility of something interesting that can happen. Here we go. Let's say we had x is greater than 3, and x is, not and, or, right, x is greater than 3, or x is less than 4. Here's our number line. This is or, so we have to graph them both. X is greater than 3, says we graph that way. X is less than 4, says we graph this way. And since it's or, it's what numbers make either of these true. And if you look closely, you'll notice that this is the same thing as saying all real numbers. All numbers make this true. Any number you can plug in the universe will make at least one of these true. Any real number. So if I plug in 5, this is true. If I plug in 10, this one's true, but not that one. But it still answers the or. If I say negative 50, this one's not true, but that one is. So there's no number that doesn't make this statement true. So all numbers make this true. One last thing I'd like to bring up. It's a similar kind of conundrum here. We have x is greater than 5 and x is less than 2. Greater than 5 and less than 2. Think about that for a second. Let me make that in purple. And this in green. X is less than 2. Okay, just so that the number line makes more sense. Alright, I didn't mention this before, but it should make common sense. We need x to be greater than 5, so at 5, we'll draw our number line that way. Remember, this is and, so we really are only concerned with where they overlap. So when I do it, I draw a very short line because I don't know where the overlap's going to be until I graph it. So this is at 2, and you'll notice because these are diverging in different directions, there is no overlap. So this is actually equivalent to saying no solution. There isn't one number you can plug in that'll make both of these things true at the same time. If I plug in any number that makes this true, this one will not be true, so it has no solution. Sometimes no solution is referred to as this. This is called the null set. There are no values that satisfy this inequality. So this has no solutions. Alright, so I think that covers all of those things. I wish I would have said them earlier, because it might have come up in some of your examples in class.